All right, hello there. I hope y'all enjoyed your snow day. If you could get out some loose leaf or your notebook to take some notes, that'd be great. Sorry, a little stuffy again. So you'll just have to bear through that with this video. This unit is called Inverse Trig Functions for Unit 8. And we're going to go ahead and get started. So a function is a relation where each input has exactly one output, and your input is x, output is y. For a trig function, the input is an angle, theta, and the output is a ratio of side lengths. So for instance, the trig function for sine, your input is theta, an angle, and you output a ratio. For instance, sine would be y over r of side lengths. Now for these inverse functions, and again, feel free to pause the video at any time to catch up with your notes. For inverse functions, you switch the x and y values. So you might have remembered this last year with Algebra 2. You would switch x and y and solve for y to find the inverse. And you'll see the inverse trig functions written two different ways. You'll see sine to the negative one, and that could be any trig function. It could be secant, cosecant, cotangent. And you'll also see it written as arcsine or arctangent. So just whether it's written to the negative one or arcsine, that is just the inverse function. Okay, now let's graph these. So to graph these, we're going to switch the x and y values. So I'm going to start with y equals arcsine or inverse sine. So now I'm going to switch the x and y values. Usually x is our angles, but now I'm going to put that under y. And sine starts at 0, 0, 1, 0, negative 1, 0. And I'll continue that on the negative side of the y-axis. And you can kind of see that mountain and valley that I used to use to describe sine with. And if I continue that, I see it's going to negative 1 and then back to 0, 1, and 0. All right, I'm going to do the same thing for cosine. I'm not going to write the table out. You don't have to have all this memorized. I'll get to the point in the lesson that you do have to have memorized. So don't freak out that I'm not writing the table. Okay, cosine, we're still going to need 1 and negative 1 in those same quadrantals. But this time, cosine starts at 0, 1. Then back to 0, negative 1, 0, 1. And that's that U shape. Okay, then it would be going back to 0, back to negative 1. It's a little unevenly spacing that I did there. Oops. Okay, then we'll do tangent and tangent and cosecant. I'm not going to do all 6 of these again because this is not what you have to have memorized. This is just kind of laying the foundation down. Okay, tangent and cotangent, we'll need our pi over 4s. Ooh, why did I put a negative there? Oops, I'm all over the place. Okay, tangent starts at 0, 0. It is your increasing S curve, so it's going to look like that. And then in between those S curves, we have asymptotes, but now they will be going sideways or horizontally. Okay, and then let me show you what cosecant looks like. So if you remember cosecant and secant, those are the ones with the parabola looking shapes, the U's. We're back to our quadrantals here. I always remember cosecant and cotangent have asymptotes at 0. And then your first parabola is at positive 1. And then you got asymptote again. And then a parabola facing down, or in this case to the left. Oop, let me do the same color. All right, then I'm gonna alternate that pattern. Why is that one drawing weird? There we go. Whatever, you get the idea. Okay, not perfect, but again, you get the idea. Okay, so why was I saying that you don't have to really memorize all this? Well, there's an issue with these graphs, and this is what everything looks like. I know the formatting is kind of weird, but you get the idea. What's wrong with these graphs is that they don't pass the vertical line test. If you remember the vertical line test, if a graph passes a vertical line at more than one point, the graph is not a function, or that function is not a function. And that happens for every single one of these inverse trig graphs. They are not functions because they have multiple outputs. Those multiple outputs are causing these graphs to not be a function. So what we have to do is we have to remove those multiple outputs. to make these trig graphs functions. We're going to choose a range that is connected and has different outputs. This is known as the restricted range or the principal values. Okay, so I'll even go back to some of the graphs. So for sine, we're going to choose this part from negative pi over 2 to pi over 2. For cosine, we're going to choose from 0 to pi right there. Cotangent is going to be from negative pi over 2 to pi over 2, and so on. So we're just going to take those little pieces of the graphs for the inverse trig function graphs. And notice how I'm using function notation now. F of x equals the inverse of sine, or arc sine, same thing. Earlier I was using y equals because I knew they weren't functions. Okay, so let's get to it. For sine, our restricted range is going to be from negative pi over 2 to pi over 2. Sine starts at 0, 0, then pi over 2, 1, and then connect your points. And that is the inverse trig function for sine. The domain is negative 1 to 1. And the range is negative pi over 2 to pi over 2. All right, moving on to cosine. Cosine's going to have a different restricted range. It'll be from 0 to pi. So we're going to start 0, 1, 2, 2, 2, and negative 1 pi. Oops. Domain is going to be the same as sine, negative 1 to 1. Range is different here though, it's 0 to pi. Notice how I'm using brackets because I don't have any asymptotes and I don't have any infinities here or any arrows. Okay, now for tangent. Tangent, we're going to go from pi over 2 to negative pi over 2. But you need your pi over 4s here. Okay, tangent 0, 0, and then your increasing S-curve. And then you just need an asymptote at pi over 2 and negative pi over 2. Notice I do have arrows pointing right and left because I'm not restricting the domain, I'm restricting the range. So with that in mind, the domain is negative infinity to positive infinity. And the range starts at negative pi over 2, but I'm putting a parenthesis because there's an asymptote at negative pi over 2. It's undefined there. To pi over 2 with a parenthesis. And if you might have noticed, excuse me, all the old ranges have now become the domain for sine and cosine and tangent. All right, halfway there, or more than halfway there. Okay, cosecant, just like its reciprocal sine, will be from negative pi over 2 to pi over 2. Okay, cosecant and cotangent have asymptotes at 0. And then you have pi over 2, 1, and then you're going to draw your curve. You're only going to draw half the parabola here. Draw it towards the asymptote. Same thing right here. For your -1, draw the curve towards the asymptote. Okay, the domain is going to look familiar here. Because we have arrows right and left, we're starting from negative infinity, going to -1. There's a point at -1, so I'm going to put a bracket, union with 1 to positive infinity. The range here starts at -pi over 2 and has a real point there, so I'm going to put a bracket, but stops at 0. And since there's an asymptote, I'm going to put a parenthesis, union with 0, back up to pi over 2. Okay, and secant's going to be pretty similar to that. It just has a different restricted range. Secant, similar to its reciprocal cosine, has a restricted range from 0 to pi. Secant starts at +1 and then an asymptote. Space those out very far away. And then -1. And then again, you're going to draw the curve going towards the asymptote in each direction. Okay, domain is going to be the same as cosecant. The range starts at 0, and there's a real point at 0. Goes to pi over 2, but there's an asymptote there, so parenthesis. And we'll stop at pi. Okay, last one, cotangent. Okay, cotangent will have a restricted range, from 0 to pi. You need your pi over 4s. Still 1 and -1 on your x-axis. Like I said earlier, cotangent and cosecant I can remember because they both have asymptotes at 0. And then you need your decreasing s-curve. And then one more asymptote. Okay, domain is going to be the same as inverse tangent, -infinity to positive infinity. Range is from 0 to pi, but because you have asymptotes at 0 to pi, 0 and pi, excuse me, you're going to put parentheses. Okay, so that's it for the first homework and the first quiz. All you have to know is these last 6 graphs and the domain and range for each, okay? So you do not have to know these first graphs because these are relations. We're not going to use these. We are going to use the restricted range so that these functions are actually functions. So you just have to know what the graphs look like, be able to draw the graphs, and the domain and range for each. All right, enjoy the snow.